Radian measure. In this lesson, you will learn what radian measure is, how to convert measures of angles from radians to degrees and degrees to radians, and how to find a function value given an angle in radians. We already know that there are 360 degrees in a circle. We also know our special right triangles. Now, when we're looking at our special right triangles, here we have an equilateral triangle where all three sides are congruent. Now let's suppose all three sides are 2 units. Well, when we construct the perpendicular bisector, that cuts the base in half, so each of those sides is 1, and the height is the square root of 3, and we can find that by using Pythagorean theorem. Again, and then it becomes a 60-30, or we typically say 30-60-90 triangle. And then again, with our equilateral right triangle, which we also call a 45-45-90, if each of our legs is 1, then our hypotenuse is the square root of 2. So when we look at radian measure, it relates to the circle in that when we construct the radius, the length of the arc for 1 radian is going to be congruent to the radius. So if we construct this sector, then our radius is going to have the same length as the arc of the angle that is created by this amount of rotation. And that angle measurement is 1 radian. So 1 radian is when the radian, or the radius of the circle, is the same length as the arc that the angle opens up to. Now we know that there are 360 degrees in a circle and 2 pi radians in a circle, so 360 degrees equals 2 pi radians. So if we want to convert if we want to determine how many radians is 1 degree, we divide both sides by 360 and we simplify. So 1 degree is equal to pi over 180 radians. And also 1 radian is equal to 180 over pi degrees. Again, we divide both sides by 2 pi to get 1 radian, and then we simplify. Convert each degree measure to radians. So here we have a 60-degree angle measure, and we want to convert to radians. So we're just going to multiply by pi over 180. So then 60 over 180 reduces to 1/3, so we get pi over 3. Then we have 250 degrees. We multiply by pi over 180. And then when we reduce 250 over 180, we get a decimal, and then we can convert that back to a fraction, and it just becomes 25 pi over 18. Now that's the exact answer. If the problem asked for a decimal answer, you could say it's approximately 1.38 with a repeating bar. And that's radians. Remember, 1 degree equals pi over 180 radians. That's why we're multiplying by pi over 180. Now we're going to convert each radian measure to degrees. And we have 5 pi over 4 and 2.75. Again, 1 radian equals 180 over pi degrees. So if we want to convert this to radians, we're going to multiply by if we're going to convert to degrees, we multiply by 180 over pi. Basically, you want to get rid of the pi's in order to convert to degrees. In order to go from degrees to radians, you want a pi in your answer. All right, so those pi's are going to cancel out because pi over pi is 1. And then we can multiply 5 times 180 and then divide by 4. And we get 225. So 5 pi over 4 is the same as 225 degrees. Now over here we have 2.75, or 2 and 75 100ths, and we're going to multiply again by 180 over pi. Now this time, because your answer is already in decimal form, it's okay to leave your answer in decimal form, and you're going to have to get decimals. So when you multiply that, you get 157.6 degrees. Now we're going to find each function value. We need to find the sine of 5 pi over 4 and the tangent of negative 5 pi over 4. Again, we want to convert from radians to degrees, so we're going to multiply just the angle measurement by 180 over pi. So we're still looking at the sine value, but when we simplify this, remember that our pi's canceled out, and we already did this calculation, so it's 225 degrees. Now, if we want to find the exact value, let's take a look at our angle measure. Well, we know that 225 degrees is going to be in quadrant 3. So we come and we draw our angle. And remember, this whole angle is 225 degrees, which makes this angle 45 degrees. So this angle is 45 degrees. Well, remember, our 45-degree triangle had a 1, which is negative because we're in the third triangle, or third quadrant, and a negative 1 because we're in the third quadrant. And then our hypotenuse was the square root of 2. So our sine value, remember, is y, which is negative 1, over the radius, r, which is square root of 2. And then we rationalize, and that becomes negative square root of 2 over 2. Now let's try negative 5 pi over 4. So again, we're going to multiply that angle measure by 180 over pi. So then that gives us tangent of negative 225 this time. Okay, and then if we want to find the coterminal angle, then we have to add 360 to negative 225, and we get positive 135. So to find the coterminal angle, remember you add 360 to negative 225, and we get 135. So now let's take a look at what that angle measure looks like. We're in the second quadrant, so here we're in quadrant 2, and our angle's coming off like this, and this is 135 degrees, which means that this angle must be 45. And again, our legs are 1, but since we're in the second quadrant, for the x value it's negative 1, the y value is 1, and the hypotenuse is the square root of 2. Well, tangent is y, which is 1, over x, which is negative 1. So your answer is negative 1. Now you try a few. Convert each degree measure to radians. You have 150 degrees and 280 degrees. Then convert each radian measure to degrees. So you have 2 pi over 3 and 1.25. Then you're going to find each function value, cosine of 3 pi over 2 and sine of negative 2 pi over 3.